Hi everybody, my name is Peter Thompson. I'm the East Asia Energy Business Leader for Arup based in Hong Kong, and it's my pleasure to be here today to present to you at what is the first Offshore Wind Day organised by DIT in Korea. And I'd like to thank them for the opportunity to be here today. The subject of my presentation is the owner's engineering services for offshore wind developments. This drawing upon our experiences in this region and in Europe, and hopefully we'll be able to give you a good overview of the sort of services that we can offer in this field. However, before I launch into that, I'd just like to give a brief overview of our company. Arup is one of the largest multidisciplinary engineering consultancy firms in the world. We have over 16,000 staff operating out of 88 offices in 33 countries. So we have a truly global footprint operating across the globe on a whole variety of different projects. In Asia alone, this is probably our strength for this particular field, in that Asia is the area where most offshore wind farms are being developed at this time. We have over 3,500 staff in region, and they're dotted around each of the major capital cities across the region, with our centre of operations in Hong Kong, which is where I'm based, where we have around 1,800 staff, and that provides a whole range of services that one needs normally for offshore wind farm works. And that includes things like structural engineering, geotechnical, electrical, mechanical, project management, seismic and wind skills, just to name a few. So we think we're very well positioned to service this market in this particular field, particularly for owners engineering services. We're also proud of our achievements as being one of the leading technical advisors for the global infrastructure market, with regular awards as the technical advisor of the year by both number and value of deals as given by the Infrastructure Journal each year. And you can see the number of awards there that we receive. So we do provide those sort of high level staff that can assess each of the offshore wind farm projects on their merits and provide good advice to our clients in this regard. We've been operating for some time. We've been operating in offshore wind for over 20 years now, drawing upon our experience from the offshore oil and gas sector. Up to date, we've been working on around 70 or 80 offshore wind farms in the European and UK areas, at a variety of different levels, but either as the sort of advisory services or actually providing niche detailed design services to our sort of contractor and developer clients. In East Asia, we've carried on a similar experience. We're operating on around 15 offshore wind farms to date. A lot of our track record is in Taiwan and Japan. In Japan in particular, where we have a large local office, we are undertaking quite a number of the initial offshore wind farm development sites, including the first one, which was Akita and Nishiro, which is ongoing at this time. So it's a very proud track record that we continue to grow, and it's something that we will use to service the markets in Korea, which we can see is steadily growing and is likely to accelerate rapidly over the years, and also the next round in Taiwan. So we're looking forward to that and growing our team locally to serve this market. Okay, back to owner's engineering. So the first question really is, what is an owner's engineer? It's actually a subcontracted role designed to support and protect the owner's interests. A lot of developers come from different positions in the market. Some are more advanced than others. So some will have their own in-house staff and others will not have so many. So what they're really doing is hiring a team of experts to provide that sort of project management, technical, and sometimes commercial support to their projects to supplement their own team. And the sort of nature of this service can either be a sort of total service or a supplementary service. It really depends on the client's needs, which can either be large or small. So it can be as small as like technical review services on a sort of ad hoc basis, or it can also be the sort of full scale start to finish service that sort of holds the hand of that developer throughout the whole process, all the way through from concept design through to the sort of operations and maintenance of that facility. A lot of these skills that clients come to us for is really for our technical design and construction expertise. This is not just from the offshore wind sector. There's a lot of complementary skills that come from the offshore oil and gas industry, as well as sort of major civil projects across the region. And this is one of the reasons why Arup's are fairly well placed in this market, because we've got over 80 or 90 years of experience in operating these types of projects. So why would you have an owner's engineer? As I mentioned, a lot of clients do have their own staff, but usually the staff numbers required for such a large project are quite high, and therefore it's quite impractical for owners to carry all of the disciplines necessary to undertake this kind of work. So they usually supplement their own staff with owners engineering staff to allow their own people to focus on more high-level tasks. It also provides an independent voice to the owner, and this is quite important because a lot of the consultants, or all of the consultants, are independent. They are not aligned with any particular um, technology or with any particular foundation system, and therefore they can really provide that sort of sense of independency to the owner, so the information they provide or the recommendations they give can be seen as truly independent. But most importantly, they can also tap into a wide variety of different technical services. These large consultancies, similar to our own, provide a wide array of different skills and experience and expertise. And it's these skills that the client can tap into in and out within the project without actually holding or maintaining that staff level throughout the project. They can also be helped to manage and control the number of complex interfacing requirements within each of the contracts. Sometimes it's just one large EPC, but even a large EPC will need managing on a number of different fronts. And it could also be a multi-contract approach, in which case the interfacing becomes much more complex, and therefore a much larger sort of project management team is a desirable situation to be in. Primarily, the owner's engineer is there to sort of reduce project risks. It's to provide some early planning by experienced professionals in the field to advise the client on the best way forward in particular circumstances as a means of sort of mitigating those risks, but also to enhance opportunities to reduce sort of capex and the sort of life cycle costs that can mount up on these very large infrastructure projects. They also help in assisting with securing project finance. To have a good brand name as an owner's engineer involved in the project gives the project more credibility, and that will attract funds towards the project as it becomes perceived as a more reliable and better gamble for the lenders to buy into. They can also assist in keeping the project on schedule. As I mentioned before, we have project management people that are very familiar with sort of programming and P6 scheduling and such like, that will enable us to track the program throughout the whole project. And then lastly, of course, we want to make sure the quality is right, and for that you need a high quality owner's engineer to provide that service. So when would you bring an owner's engineer on board? Well, to be honest, it really is up to the owner. Any time is really the answer to that, and it's really up to the owner's ability themselves as to how much they can do themselves. Typically, experience in Asia is that many of the developers are fairly experienced. Some of them have come over from Europe, and therefore they do carry their own in-house teams that can do a lot of the initial planning works. But that's not always the case. You do have some less experienced developers who need to be helped at the very early stages. And to be honest, as I mentioned before, it also provides credibility to that project with the owner's engineer can assist in providing some of the early and strong financing that's required to finance the size of the types of project we're talking about. It's widely considered that actually, if you're really looking at a very large wind farm, it's really good to get the owner's engineer involved very early on, because the number of staff you require can be quite intense. And it's always good to have that owner's engineer familiar with the client's direction and aims for the particular project. So they can follow the project throughout the whole life cycle of that project and provide the sort of services that are more bespoke to the client's needs. And these are things like, I've given a list here of site location, some technical feasibility of the solutions being offered, perhaps even offering alternative cost-effective solutions to the client. As an alternative to what they're currently proposing. They can help defining the schedule and also providing a greater guarantee of the project costs. They can also help in the EPC attraction and the selection of EPCs. Obviously, there's a high risk on these EPC contractors to take on the work, and for them to see a high quality owner's engineer working alongside them, ensuring that the interfaces are well managed and detailed in the specifications gives them greater confidence to bid. It also allows them to remove or reduce some of their uncertainty. It reduces the potentials for claims and delays. So all in all, I think it's better for all parties to have somebody on board that's a strong contender. As I mentioned before, some of the developers are strong in their own right, but really having another supplementary owner's engineer on board to provide an added support to the project, I think is an all-round beneficial to all parties. So what are the main duties of the owner's engineer? And I've given just a few of them here. To be honest, there is no limit in terms of the duties that one can provide as an owner's engineer, but these are some of the sort of main duties that one would expect to be offered, but it's not an exhaustive list, and it can be something that can be interchanged or modified to suit the client's own particular needs. The first step is really to define and review the project scope, to understand what the project needs and whether it's a well thought out project for this particular location. If that was found to be the case, then we would conduct feasibility studies and site selection studies, as well as alternative analysis to determine the way forward for the project. And then we would look at the sort of technologies and being applied and whether they're suitable for this particular project. Once all this has been done and there is a project in hand, we would then move forward with the sort of permitting assistance. There's a lot of permitting that's required for the local regulator to ensure that the project is to the benefit of the local population as well as the local government, and to ensure that it doesn't infringe upon any of the sort of legal issues that may pervade for the development of such a large project, particularly in sensitive areas as the sea, where there's environmental consequences. So there are some environmental concerns that also need to be addressed in terms of sort of EIAs, environmental studies, as well as social studies, particularly if you're looking at investment from maybe the European banks and other such institutions. Once this is clear, we would then look at the sort of early project schedules and design criteria, and this criteria will be used to understand what the client's needs are, because we're going to EPC. It's really a performance specification. You know, the designs put forward are really there as an indicative design, and it's really about understanding what the performance requirements are of the client, which are then laid down in the specifications for the EPC contract, for the EPC contractor to be bound to. We would then assess and evaluate the budget and identify sort of financing resources to ensure the project can move forward, before then launching into sort of technical specifications and contract administration documents, and then procurement of the EPC contract, as well as the sort of construction works and the construction management. And I'll talk about these in a bit more detail later on. So how to select your owner's engineer? There's many ways you can do this. Many firms now offer this sort of ownage engineering services as a specific offering. So I think these are very well known in the industry, and the clients will know which of these companies are able to provide that offering. And it's one of the offerings that my company Arup does make to the industry. It needs to be, I think one of the most important points is to have a close and trusted relationship between the owner's engineer and the client. Obviously, the owner's engineer is working on behalf of the client. They really need to understand the client's needs. But as I mentioned before, they need to have the independence from the EPC contracting organizations to avoid potential conflicts and to serve the client in respects of determining the sort of requirements he needs for that project. There's a number of choices of different owners engineers, either from the large multidisciplinary firms such as mine, or sort of small specialist firms or local firms. They all have their sort of various advantages and disadvantages. The large firms provide the sort of range of skills and the strength and depth of knowledge that one may need for these large projects and large civil engineering works, but they can be expensive. The smaller ones provide a more niche service focused primarily on sort of offshore wind sector, but they may not be able to provide the overall coverage that a large multidisciplinary firm can provide. And then of course you've got local firms as well, which is a good way of they may not have the sort of necessary skills and track record, but they do understand the local market. So, you know, an owner's engineer can actually be made up of more than one company, and you can have some of these local smaller companies working under the umbrella of the larger multidisciplinaries. And as just as the final points there is, I mentioned before, you need to have a good understanding of the owner's engineers. You need to have a good familiar relationship with the individual employees. that need to work very closely with the client to ensure that we understand exactly what they need and we move the project forward in the direction that they would like. So these are the stages. I've written them down into sort of three main stages. There's planning and design, which is by far the largest input for the owner's engineer. There's the procurement stage, which is when you start bringing the EPC contractor on board, and then finally you've got the construction phase. And it's really up to the owner's engineer or the owners when you bring the owner's engineer on board. But you know, by the look of this list, the biggest value comes very early on at the planning and design stage, and it's really up to the client how they then move forward through these various stages, and I'll talk about some of these items next. So the first stage is the planning and design stage. So we're looking at quite a number of different services. The first one is really the initial target site identification and assessments. And this is really looking sort of prospecting for the suitable sites, the comparison of the different attributes of each site to ensure that the client chooses a site that provides the most optimum solution for them to develop, to minimize capex and opex, and to maximize the LCOE for that particular developer. Once we've chosen our particular site, we then, as part of that work, need to be looking at sort of wind resource monitoring and assessments. And for this, you know, in the past we used to use this sort of fixed-based LiDAR systems. These days it's moved towards the floating LiDAR. So we can help with sort of the planning and implementation and suitable wind measuring equipment in the sea, the data collection and compilation, as well as the interpretation of the results, and then the development of the business case. Alongside this, it's important to do some geotechnical and geophysical assessments to understand the nature of the ground conditions, and in particular the seabed and the subsoil conditions. So we can help with the planning and procurement of the geotechnical and geophysical surveys, the derivation of the geological models thereafter, in order to sort of guide the design process in terms of the foundation system and technology that should be adopted, and the sort of suitability of those systems for this particular site. And that can actually be quite an expensive operation to be done, but in terms of the risk for the project, to have a really good understanding of the ground is so important when you're talking about sort of offshore engineering. You need to understand the ground conditions that you're working in. Of course, the sea is also a very environmentally sensitive area. There's a number of different groups that are operating. You obviously got a number of sort of sea mammals and sea corals, as well as social issues such as the fishermen and such like. So it's very important to do an environmental impact assessment study very early on to understand what these constraints might be. So it will facilitate the sort of planning and procurement of these environmental survey campaigns so that we can negotiate the local and international environmental regulations to ensure that the project is compliant and is not something that will become a showstopper later on in the project. The next important point is looking at the energy yield. So once you've done your monitoring campaign, you'll have a whole series, maybe 2 years worth of analysis results from the floating LiDAR. And from this, you can do an interpretation of the wind monitoring results using sort of specialized software such as WindPro. We can then undertake an assessment of that sort of microclimate at the selected wind farm site. And from that, we can determine an appropriate site layout, the number of turbines one requires, and the direction of those turbines to maximize the annual yield from the wind farm. And in conjunction with this, we'll be looking at the turbine selection. So we'll be assessing the suitable type of turbine that one should use, the class and the size. We should be looking at their optimal performance, either in sort of normal or extreme wind conditions, and the impacts of or potential impacts of turbulence as a consequence of the layout. We'll be looking at cost and efficiency. Obviously, you don't always go for the most expensive and biggest wind turbine. It really depends on the type of wind that we're dealing with and the location that we're in. So we would try and find the most cost-effective solution that maximizes the power output to our clients, but also makes consideration for the sort of operations and maintenance of the wind farm in the long term. Once we've got all these sort of initial data, we would then launch into the sort of initial concept and pre-feed designs. It's an important stage of the design because it forms the basis for the EPC tendering. And we would look at the development of those sort of initial concept designs and pre-feed designs, whether it be sort of monopiles or jackets or something more innovative like even floating systems or gravity-based systems or suction can systems to cater for the different ground conditions that one might expect to, or one might find at their particular site. And then once we've had these sort of pre-feed designs, we can use them as initial cost estimation tools to inform our client of the likely project costs and sort of facilitate the planning in the latter stages for the purchase of the balance of plant equipment. After that, we need to look at grid connection. In fact, all of these should be really looked at in parallel, because each one of them could be a potential showstopper or difficult challenge or constraint for the project. But grid connection is another big one, really. You need to make sure that the name of the game is really to generate power, and you need to make sure that there is somewhere to take this power at the end of the day. So you need to locate the availability of local substations in the existing grid. You need to look at the grid capacity to make sure that the power that you plan to produce can be taken. And you need to look at things like curtailment risk and such like to determine whether or not we'll be able to yield the maximum power output that we plan to do so. And also the cable arrangements, another big or another large ticket item for the overall capex of the project. So you need to be looking at the inter-array cables, whether you need an intermediate substation or whether you take those array cables directly to shore. And it really depends on the distance. It really depends on the sea conditions, and one can look at this to optimize the costs. And then, of course, you've got to do some grid impact assessments to determine the impact of the power that's generated from the wind into the networks to ensure that it doesn't interrupt the existing services and is able to accommodate the loads we're talking about. Met-ocean studies is another one that needs to be considered. Obviously, we're out in a harsh environment. We're working in the sea, so there's going to be a comprehensive study required into the oceanographic environmental conditions, and that's things such as bathymetry, the wind, the waves, current, and temperatures. And for this, we've got our sort of in-house people to basically look at these types of things. Project programming, obviously, these projects work to a very tight timeline with many different activities ongoing at once. We want to minimize the expense as far as possible as we go through that process, but we also need to get meaningful results as we do so. So project programming is an essential part of the process, where we would essentially map out the whole program and identify the sort of key program risks. We'd undertake monitoring of that program to mitigate any delays, and also be used to determine the schedule for equipment purchasing and planning. Local permits and licensing is, as I mentioned before, there is a need to ensure that we comply with the local regulations. So there is a whole sort of range of permitting and licensing issues that one needs to go through, which the owner's engineer can assist with. And then, of course, you've got some risk assessments. The whole process is fraught with risk, and it's really the owner's engineer's jobs to recognize these risks, to monitor these risks, and identify suitable mitigation measures to ensure that these risks are minimized as far as possible throughout the project lifecycle. And a lot of this is done by essentially undertaking additional investigations or additional assessments in order to understand those risks better, in order that we can sort of find a way forward that minimizes the risks to the client. Then, of course, you've got CapEx and OpEx assessments. It's obviously very important to understand how much these wind farm developments are likely to cost. And for that, we have a whole series of experience with different wind farms across the world. So we use that data to benchmark our analysis tools to provide as accurate as possible our CapEx and OpEx estimates for a particular project. And we can also develop suitable contingencies to account for any of the potential risks that we've identified from the earlier risk assessments. Once we've gone through that stage, and once we've come up with our provisional design or pre-feed design for the wind farm, we can then launch into the next phase, which is the procurement of a suitable EPC contractor. And there's a number of EPC contractors around the world familiar with offshore wind farm works that are able to be introduced to the project or invited to the project to undertake these type of works. The first stage is really to work out or to determine the appropriate contracting strategy for the project, and this really depends on an assessment of the project requirements and the local availability of skills, as well as the experience of the developer themselves. And then we can consider the local legal framework for the development, as well as in order for us to come up with the sort of most optimum contracting strategy for the works, whether it's a sort of full EPC contract or EPCM or some sort of multi-contract arrangement, is something that needs to be discussed and determined with the client. Once this has been decided, we can help in the preparation of the contract documentation. So that's really a detailed and comprehensive set of specifications and contract documents to essentially be able to go out to the EPC contractors for request for their pricing. We can also then provide EPC tendering support. So essentially the EPC process will go on for several months, and there'll be some administration work that's required throughout that tendering process, sort of responding to queries and issuing tender addendums as necessary in order to sort of allow the EPCs to understand the project as closely as possible in order for them to understand their risks and hopefully attract a much lower and competitive price as a consequence of that process. So you really need to follow that throughout the whole sort of EPC tendering process to ensure that that aim is achieved. And then lastly, you've got the O&M strategy. So at the end of the day, when the facility is built, we need to have an organization to manage the operations and maintenance for the particular wind farm. This will be focusing on things like the operational safety and control, also the contracting strategy for the O&M services, as well as the logistics for the vessels. And then lastly, once we've appointed the EPC contractor, the next stage or the final stage is really to push on with the construction works itself. And for that, the owner's engineer could provide construction supports. This is the provision of sort of technical supervision works for both sort of workmanship and quality assurance purposes, but also we can provide the sort of health and safety overviews necessary to ensure the safety of the project and the personnel working on that project during that construction period. There's also regulatory compliance monitoring and recording that's needed to ensure that everything is built in accordance with the local regulatory environment, and also contract administration activities to ensure that each activity is recorded in an appropriate manner such that any issues that may arise later can be backtracked through the records to understand the nature of any construction works that may have led to any particular problem. In many jurisdictions, there's a need for a local engineer of record to sign off the drawings, to provide a level of local assurance to the regulatory authorities. So again, if you have an owner's engineer with a local office that provides these types of services, it's of benefit to our clients to be able to tap into these people, to allow them to be used for the project, to sort of work together with the construction support team in providing the overall supervisory services. Once the facility is constructed, we can then move into the next phase, which is sort of post-construction really, which is the turbine performance monitoring. And for this, we can provide services looking at sort of instrumentation of the wind turbines and the structure to identify any faults. And this is something that can be fed into the O&M strategy. It can be used as an O&M tool to be able to detect faults before they happen, in order that maintenance can be done in advance to avoid a particular outage at any particular wind turbine. It can also help with the sort of plan for inspections and maintenance schedules, which is, when you consider the costs of some of the operations and maintenance activities and the distance from shore, it's very good to have some early insight working from onshore using sort of remote sensing techniques to identify these problems early. And then finally, life extension. This is something that we offer in our company in particular. It's something we're focusing on, particularly in the UK, where some of the assets are becoming fairly old. So we are able to provide a service where we can monitor the structures either with real instrumentation or with virtual sensors to measure and record the fatigue cycles on the foundations. And from this sort of real-time monitoring of the turbines and the substructure, we're able to guide the operations to extend the life of the structures and provide a sort of technical or scientific means of justifying that an extension of life should be permitted for the particular structures being considered. Okay. Hopefully that gives you a good overview of the owner's engineering services that can be provided to offshore wind. However, should you have any further questions, I'm happy if you would like to contact me on the details shown on this slide. So thanks very much for your time and thanks for listening.